Okay, good morning. So let us continue the lesson. So we started talking about quadratic functions yesterday. If you remember, the functions of this form are called quadratic functions. F of x equals to ax squared plus bx plus c, where a, b, and c are real numbers, but of course a is not equal to 0, otherwise we are not working with a quadratic function at all. And then yesterday we discussed a little bit about the graph of these type of functions. The graphs are called parabolas. And then I told you that in this lesson we have only two types of parabolas. The parabolas that are opening up, they have a minimum. Yes. And the parabolas that open down, we have a maximum. So this point is the minimum point, and this point is the maximum point. If I want to refer to both of them, I call them an extreme point or a turning point. Yes. And we also discovered, more or less by just trial and error, that if this number is positive, then I am facing this situation. If this number is negative, I am facing this situation. Yes. Let us try to understand this a little bit from algebraic point of view once for all. Yes. Do you remember? And then the answer, the questions that we answered yesterday was, if I give you a function of this form, if I ask you to find the maximum point or the minimum point, you are able to do that by just simple algebra. Yes. So, but we did it case by case. We can do it algebraically once for all and get a formula for that. Of course, the formula is not given in the book, but if you use the formula in the exam, that's okay with me. I want you to understand that and then use the formula if possible. So let us try to understand this behavior of this function. So you see that if a is not 0, there are two cases left for me. Is either a is positive or a is negative. Yes. And instead of writing f of x, let me just write y ax squared plus bx plus c. And if you don't mind, let me just follow my method. I want to find these extreme points of this function. So do you remember what was the first step to do? Is to divide, for example, by this a. Yes? So I divide by a. This becomes x squared, this becomes b over ax, this becomes c over a. Then do you remember what was the next step? The next step was actually to find a term that I have to add here to make the square pattern reveals itself. So we go to scratch paper, I take the number in the middle and I divide it by 2. When I divide this by 2, it means that I multiply by 1 over 2. Which is b over 2 over a. Yes? And then, do you remember, I told you that you square this number, which becomes the numerator squared divided by the denominator squared. So that is the number that you have to add here. So what happens, it becomes y over a is equal to x squared plus b over ax. I add that number here, but I cannot just add, I have to subtract that to compensate for this addition, yes? So in principle, this number is nothing except 0, and then I have plus c over a. So that is completely valid. I added this term to compensate for this extra term. I subtracted the same thing, so it means that I have done nothing. And then I have c over a at the end. But what is the benefit of adding and subtracting the same thing is because the first 3 terms is now making actually a squaring pattern. So this becomes y over a is equal to. So if I ask you what can I write instead of that, you would say that it becomes x plus b over 2a totally powered to the power of 2. Okay, we can double check that. Why is that true? Because if I raise it to power 2x squared appears there. 2 times the first one is 2x, times b over 2a. That 2 and this 2 are cancelled, so it becomes b over ax, and that is exactly b over ax. And finally, the second one to power 2 becomes b squared divided by 4a squared. That is correct. So then I am left with these two terms that I have to write here. So if you don't mind, let me write the positive one first, and then I will write the negative one. Yes? That's completely, I'm just following exactly the method that I described yesterday, but instead of working with numbers, I am working with letters, so that's algebra. Okay, and then I want to simplify this expression a little bit. So I go to scratch paper, c over a minus b squared over 4a squared. Yes? So what is the common denominator? I have to rescale this fraction so that the denominators become the same. So what I do, I multiply the numerator and the denominator by 4a. If I multiply this by 4a, it becomes 4ac. If I multiply this by 4a, it becomes 4a squared. So this fraction that you see here is exactly as this equal to this fraction, but the good point is that the denominator and the denominator of this one are the same. So this means that what can I do? I can write 4a squared in the denominator and just simply subtract them. And this formula is a little bit familiar. This combination is familiar for you. This is not delta. This is opposite to the delta, because delta was b squared minus 4ac, but here this is 4ac minus b squared. But of course, don't get confused. I am not solving an equation. Yes? Anyway, so what can I write? I can write y over a is equal to x plus b over 2a squared. And then instead of this expression, I write this compact form, which is 4ac minus b squared over 4a squared. Yes? Now, I hope that you agree with me. This number is non-negative because it has an even power. So this means that this whole combination that you see here is greater than or equal to what? Can you tell me? This number, whatever x is, I don't know what x is, but I don't care, because whatever x is, this whole combination is a non-negative number. So then the whole combination becomes what? Yes?
It's greater than 4ac minus b.
This one, yes, exactly. 4ac minus b squared over 4a squared. Yes? So, now what is this one? If you see that y over a is equal to this expression, but this expression itself is greater than or equal to that expression, so this means that y over a is greater than or equal to that expression. So far, so good, yes? But now look here, I know that a is not positive, is not 0, but I don't know if it is positive or negative. And it makes a difference here. Yes? So I have to consider two scenarios. One scenario is that what happens if a is positive? If a is positive, I can multiply everything by a. I multiply both sides by a, but because now I am assuming that a is positive, I can and I have to keep the sign as it is. I don't change the direction, yes, because I am assuming that a is positive. If a is positive. But this a and that a are cancelled, so I get y is greater than or equal. This a here, I have a times a. One of those a's and one of these a are cancelled, so what is left for me is 4ac minus b squared. And now I hope that you agree with me. This is the proof for this. If A is positive, I showed that y is greater than or at least equal to this. So what does it mean? Do you think y has a maximum or a minimum? This tells you that y is greater than or equal to this number. So this means that the minimum value of y is this number that you see here. So this means that the minimum of y is equal to 4ac minus b squared divided by 4a. Okay, can you tell me when this minimum occurs, when it is attained, for which value of x I can reach to this minimum? Yes?
Minus b over 2a.
Minus b over 2a, yes? Do you remember? Because if I want to reach to this minimum, if I want to reach to this value, it means that I have to have equality. I have equality here, if and only if I have equality here, if and only if I have equality here, if and only if I have equality here, and finally if and only if I have equality here. But this becomes equal to 0 if and only if x is minus b over 2a. So this is attained at this point. Yes? So this means that the minimum point is equal to these numbers, minus b over 2a and 4ac minus b squared over 4a. This is the minimum point. The minimum value, the minimum is equal to 4ac minus b squared over 4a. So if a is positive, so let me underline this. So this is just the summary. So you see that this is the power of algebra. We just, instead of solving the problem case by case, I solve it with letters once for all, and I get the formula. So you see that the minimum is 4ac minus b squared over 4a, and the minimum point is this. When a is positive. But what happens if a is negative? If a is negative, everything remains the same, unless when I multiply by a, I am not allowed to keep the sign as it is, I have to flip the sign. And then this means that I have a maximum. Yes? So let me just do it here as well. Okay, so what happens if a is negative? So far, you see, every calculation that I have done up to here is still valid. But this part was depending on the sign of a. Now, this I have to be careful. So still I have the same thing. Y over a is greater than or equal to 4ac minus b squared divided by 4a squared. I still have that one, but because a is negative, when I multiply everything by a, I have to clean and flip the sign, because a is assumed to be negative this time. Yes? So if you don't mind, we can consider this to be, let me give it a name, star here. Yes? And then I would say that's based on a star. I get this one again. But this time, since a is negative, when I multiply this star by a, I have to remember I have to flip the sign. But the rest is the same. This means that y is less than this time, or equal to this amount, 4ac minus b squared over 4a. And now it reveals itself to you that this is a maximum value, yes? Because y is less than or at most equal to this combination. So this means that y doesn't have any minimum. In principle, y has a maximum, and the maximum of y has the same formula. When it occurs, exactly at the same number. Yes? So this means that if I ask you if A is negative, then the maximum point, the max point, is which point is the same formula. Yes? But the interpretation is different. When A is negative, I get this relation instead of that relation. Okay? In that form, it is clear that y has a minimum because it is at least equal to this. But in this case, y has a maximum because it is at most equal to that. But the formulas doesn't change. The formulas are the same. So the max point is this, and the maximum, if someone asks you about the maximum, you should say 4ac minus b squared over 4a, and then when it occurs at the point minus b over 2a. So this is the end of the story. So we solved it, but this formula is not in the book and it is not in the formula sheet, okay? I will be, so it is up to you if you want to use it or not, but it doesn't mean that if you memorize it, you don't understand it. So it is very important to understand what is going on, and if you want, you can use the formula. So I don't know, for some reason, for me, it is easier to remember it with this trick. And I write minus delta over 4a. Because I told you that delta is famous for you right now. It's b squared minus 4ac. Again, don't get confused. I am not solving an equation. Delta appears in solving an equation. But of course, delta is that combination b squared minus 4ac. But here it is 4ac minus b squared, so it is minus delta. So if you want to memorize it easier, you can use this idea. Which I don't recommend. I want you to understand what is going on. Any questions? So in principle, finding the maximum and minimum of a parabola, the quadratic function, is very simple. We answered this, yes? But the algebra was simple here. If I raise it to a higher degree polynomial, there is no guarantee we can use the same method to find. And it is not possible, by the way. Later, we will see in Math 3C that we can find maximum and minimum points of any graph, more or less, by another method, which is extremely important, and that is differentiation and the notion of derivative. But to this year, you can't find the maximum and minimum of a parabola. So this, remember, if you have a quadratic function, and if they ask you about the minimum and maximum value, you can find that. Yes? Any question? Okay, for example, let me solve one practical problem here. Okay, so how see that? So for example, I don't know, we can imagine something like this. So assume that you have a little bit of fence at your disposal. Yes. So I don't know, you have, let us say, 10 meters of fence. And then you're 10 meters, yeah, it's good. And then what you want to do, you want to make a fence around the garden. You want to make a garden for yourself, a small or big one. But the point is that in your warehouse, you have only 10 meters of the fence, and you don't want to spend any money. What you are doing, so this is the wall. You don't need to put any fence here, but you want to do some fencing here. And then this becomes your garden. Yes? Now, the point is that if you have 10 meters of fence, usually you prefer to have a bigger area for your garden. Yes? So now we want to fine-tune the problem in a way that I can cover the highest area with just 10 meters of fence. Is that clear? The problem is clear. So I have 10 meters of fence. Of course, it would be very crazy if I want to do it like that. Yes? Because it is so narrow. I don't know. It depends to you. So, but this has an area. I can make it very narrow and long. I can make it reasonably like this. Anyway, my goal is to make this area as big as possible, but I do not want to spend even 1 crown to buy more fence, yes? This is called optimization. So you want to optimize something, okay? And that is really a practical problem. What is your intuition here? How do you do that? I just want to give you this practical problem. It is a real life problem, isn't it? So you have 10 meters of fence, you want to fence around 3 sides, like a rectangle. And then you want to cover as big, as large as area as possible. So you see that you want to optimize something. Here, the area is your target. You want to make it bigger. I'm using the word optimize here. In this case, optimization means maximizing. But sometimes optimization is minimizing. For example, if you want to run a business, you want to minimize your loss. So in that case, optimization is minimizing the loss. Yes? Or you want to maximize your profit. Optimization means maximizing profit or minimizing. So optimization is a very important problem in mathematics that we want to address. Later we will solve harder problems, but here, if I remember correctly, the function involved will be a quadratic function. So what is your intuition? How should I do that? Yes? Intuitively and then from calculational point of view. Yes?
Intuitively, I would guess that we would probably want to make it pretty thin against the wall so that the side which is parallel to the wall is as long as possible. Because then maybe, because we get the wall for free, then we're maximizing how much free wall we're getting.
Okay, let us check. Let us check. That is your intuition. Any other opinion? Yes?
I think the exact opposite, actually.
Exact opposite, okay.
Make it as equal, the sides as equal as possible, I think.
No.
But
The sides are equal.
no, I don't.
If you want, let me make it 12 so that you can divide it by 3. So I want to not to make it complicated because of numbers. So if your intuition is correct, you mean 4 meters, 4 meters, 4 meters. So can you give me numbers, Rasmus? No, because as thin as possible doesn't make sense.
Yeah,
yes?
then it
you
would-
need to give me numbers and practical.
Yeah, then it would probably if I assume that my logic is correct, that it gets the better the thinner we make it, then of course the best scenario would be to make the orthogonal sides to have no length at all and just make completely flat. And of course, then
No, in that case you are minimizing.
then of course it wouldn't have any area. So.
No, but you are minimizing.
Yeah,
That
so
intuition
that
is
can't-
correct if
that
you want to
can't be
minimize the
best
area, because
way.
that in that case the area will be 0,
Yeah,
and probably that's
so
correct.
my logic clearly doesn't work.
Yeah.
I would say we split the amount of fence we have so it's equal on all sides, so it would be 4, 4, 4.
Okay, so your intuition is more or less like Oscar's intuition. Let us check, by the way. Okay, but first of all, how can I solve it using these ideas we learned here? So you can think I can agree.
Om man tar 3, 3 och 6, då är det 18. Det funkar inte.
Okay, so let us try to solve this problem a little bit systematically. Okay? So what we do, we can imagine this is the way that we fence it, okay? So then I would say that this is a rectangle. So if I call this x, this becomes also x. Yes? And then this one I don't know, might be it would be the same value of x, if your intuition is correct. But I cannot, if I write x here, it means that I have already decided that they have to be the same. So this means that I use another letter here, so let me call it y. Yes? And then the target is the area, so let me call it a. So what is a here is x times y. Yes? I want to maximize a. Is that understandable? But I have some relation between x and y. x and y are not completely free because I have only 12 meters of fence available. So it means that the total length you see here should be 12 meters. Yes? So this means that 2x plus y is just 12 meters. Yes? What I do, I calculate y from this equation and put it here. Yes? So then y becomes 12 minus 2x, and I plug it here. So what happens here? This becomes x times 12 minus 2x. This becomes area. But let me multiply this in. It becomes minus 2x squared plus 12x. And this is your area. Your area depends on x, so it is a function of x. This is your target function. Okay? And now, what type of function is this? It's a quadratic function. Agree? It's a quadratic function. Do you think this quadratic function has a minimum or has a maximum? Yes, Rasmus, do you want to say
It
something?
should have a maximum.
Yes,
Because
because
it's
this
split.
a is negative. Yes? And then there are two questions that I can ask. I can ask what is the maximum area that I can cover? It's good to know, but it is not very practical. Practical is that how to do it. So be careful. This is understandable now. When I ask you about the maximum value, here in this problem it means that what is the maximum area that I can cover? But that is not your problem, yes? Because nothing will be changed. You want to do how to do it. You want to know how to do it in order to achieve the maximum. Okay? And then we have answered that question here. It's on the board. If I ask you what is the maximum of A, now you can answer it. What is the maximum of A? The formula is in front of you. It is 4AC minus B squared over 4A. But can you tell me what are A and B in this function? A is negative 2, B is 12, and C is 0. Yes? So if I ask you what is the maximum of area, the maximum area is equal. Instead of C, I put 0, so the whole thing cancel out. Then minus B squared is minus... that's very strange. The maximum cannot be negative. Oh, sorry. The maximum, I made a mistake here. No, that's
becomes
correct.
positive because
What?
A is negative, so it does become positive. Right?
No, C is 0, unfortunately here.
Yeah, but
Aha, A is 0.
body-
Thank you very much. Thank you. So C is 0. So this is, let me write everything. 0 minus B squared is 144, and then divided by 4 times A. Yes, you are right. Thank you. 4 times minus 2. So then it becomes minus 144 divided by minus 8. So what is that number? This is positive. I divide by 72, and then 36 and 18, yes? That's 18. So 18, because it was written in meters, and that's an area, so this becomes 18 square meters. So if I don't want to spend even 1 crown more, I cannot cover more than 18 square meters with what I have. But that is not my problem. My problem is how to do it to achieve the goal. So even though knowing maximum value is also interesting to know, but more practically I want to know how to do it. How to do it, it means I need to know what are the values for x and y. How can I answer that question? That question is also ready-made here for you. When this max occurs, when this max is achieved, it is achieved when x takes this value. Is that understandable? So x takes this value, minus b over 2a. So it is minus, what is b? b is 12. 2 times a is minus 2 again. So what's the answer? It is 3. Yes? So x should be 3. When x is 3, what is y? What is y? 2x plus y is 12. So if x is 3, this is 6, y is 6. So none of the intuitions were correct actually. Yes? So x should be 3 meters, y should be 6 meters. Is that clear? So it means that if you really want to maximize the area of the garden that you can cover, this is mathematics. You have to put 3 meters here, 3 meters here, and 6 meters here. Which probably shows that none of the intuitions were correct. Even I couldn't guess it probably, I don't know.
Isn't that strange?
Is it?
Why would it specifically be that? Like, why? Why
That's a good and deep question. but this is indeed mathematics. Yes?
Yeah.
If you want to, you can draw the graph of this function using GeoGebra and to see that it really occurs at this point or not.
So does x always have to be half of y, and then that's the maximum area?
Yeah, in this case, would say yes. This seems to be the case. Do you have any questions?
Well, technically, you could make the area as small as possible, stand inside it, and everything outside of the area will be the new area, and that would be the highest area, the biggest area.
Of course, it depends how much of this land you own. Yes, that's also possible. So in that case, you are right. If you own everything outside, then of course I will make a point here and I don't need to put an fence. Yes, that's good. Anyway, I couldn't see this myself before calculation, but this is, we have to trust on the calculation. So I mean that this is a very nice problem because you see it is connecting the idea. So you see maximize. So if I tell you, if you need, so this max is good for the one reason. If you calculate max and it turns out to be 18, if you need more than 18 square meters, it means that you have to spend money. Yes? So you don't even start the work. You go and shop something and come back. But if it's 18 square meters is enough for you, then you have everything that you need right now. Yes?
But was it in the problem that it has to be a rectangle?
Yes.
Okay.
So I told you, so that's one part of the problem. Might be you can make it like a circle or whatever, yes?
Mm.
So that's also a nice question. So if I want to have it as like a circle or I don't know what in any other shape. So, but that was given in this problem, that I want to have my garden like a rectangle. Yes? Yes?
Yeah, I tried making a circle with like one edge touching it, but it's small for me.
Is it?
Yes.
Yeah, so we can of course calculate because I don't know how do you want to do that? Do you want to make the fence like this, for example? Did you calculate for this
Yes.
case?
I
Okay, for this case, this parameter is supposed to be 12. Yes? So what is that? So this means that the parameter, if the radius is r, so the parameter has a formula for a circle, that is 2 pi r. This is supposed to be 12, so it means that I calculate the radius of that circle. It becomes 12 divided by 2 pi, which becomes 6 over pi meters. And then let us calculate the area. The area becomes what? Pi r squared. Then it becomes pi, this 1 to power 2 is 36 pi squared. But this pi and that pi are cancelled, so it becomes 36 divided by pi. But pi is a little bit more than 3. So when you divide 63 by a number a little bit more than 3, it becomes a little bit less than 12. But actually we are able to get 18 square meters. So between circular arrangement and rectangular arrangement, definitely rectangular one will win, yes.
But if you have something like a half circle, so 2 points connect to the house.
To the half circles, okay. So what you mean? We can check. I know, but what I'm saying that you don't need to be confused for this problem.
No.
But the questions that you are asking are interesting questions. This is why I'm trying to understand them. For this problem, they have mentioned a rectangle. So what you mean is to make it a half a circle like that. Yes? Is that what you mean? Okay. So in that case, the whole 12 meters is used for half a circle. So instead of having 2 here, yes, I will have pi r equals to 12. Yes? And then when you divide, it becomes 12 over pi. And then you put it here, but the area also will be half of this one. Because then this would be half of this one, and this one squared is what? Is 144. And then pi and pi are cancelled, so this becomes 72. Am I right in my calculations?
Yes.
Yes. And in that case, you are right. This area becomes bigger. Yes? Because 72 divided by 3 point something is definitely larger than 18. Actually, substantially larger than 18. Yes? Yeah. So, yeah, if you want, it is better to do it in that way. If you just want to cover some area. But here they have emphasized that you have to do it in rectangular form. But of course, that is also tricky. Is this the biggest possible one? Might be you can make it as half an ellipse. Is it better to do it in that way? That is hard, by the way. There are no closed formula for the perimeter of an ellipse. You can find the area of the ellipse. So if you have an ellipse like this, so ellipse is a little bit like circle, but you have 2 axes. One is called the major axis, one is called the minor axis. These are the longest one and the smallest one. If this half of this is A and this is B, the area is simply pi AB. The area. This, of course, you need to wait to see integral calculus to be able to prove this. But there is no formula for there is a formula. People can calculate it to any precision that they desire, but the formula is not a closed formula, meaning that getting A and B, putting it in that formula simply to get a number for the parameter. Yes? But even in that case, who knows, might be a very strange shape will maximize the area. So then the problem becomes very, very hard if you want to let all possibilities coming in. But this is a very nice question. This is nice imagination. Thank you. Okay, and by the way, I don't know, I myself prefer round shapes. They are more beautiful than shapes with corners. So then definitely I will make it round, yes? Because, by the way, circles are more beautiful than squares, aren't they? I don't know. Beauty is somehow related to symmetry, yes. And the symmetry of a circle is actually a circle is completely symmetric, because even if I rotate it 1 degree, you cannot recognize that I have rotated it. But in order for a square not be recognized, I have to rotate how much? 90 degrees at least. If I rotate 90 degrees, you will not recognize that I have rotated. But if I rotate it 2 degrees, you immediately realize something has changed. So this means that this is more symmetric than the square. And then apparently in human brain, art is somehow related to symmetry apparently. So the more symmetric the shape is, the more beautiful we probably. I don't know. That is from art point of view. Okay. Anyway, but I think beauty is really related to symmetry. Okay, so any questions here? So that is one practical problem that we were able to solve with these ideas. So maximizing and minimizing functions are sometimes practically important. But you cannot solve a very big diversity of these kinds of problems because we were lucky that in this problem the target function happened to be a quadratic function. But there are many, many problems that when you want to optimize a function, it turns out to be a trigonometric function, a polynomial function with higher degrees. In those cases, we do not have any formula yet. So we have to wait until Math 3C to be able to do those kinds of problems. Yes? Is that understandable? Okay, let me see if there are any kind of these problems. I think there are many nice problems of this type in the book. I will come back to them later, okay? But this was a good example that we just did it here. Okay. I want to continue a little bit more, then I will give you time to practice on your own. Okay, I think let me not start something new. There is something on my conscience, so I have to tell you here. This is not exactly right. Yes? So why is that? I told you that if A is negative, then you have only a maximum. But this is a practical problem. This is not in the world of mathematics. This is in the world that we are living. We have some fence and we want to do something. Yes? This is not a complete... So if I ask you to draw the graph of this function, can you tell me how do you draw that? This function. For example, I give you GeoGebra and I want you to draw the graph of this function. How do you do it using just GeoGebra? Can you tell me? Yes?
I write in the function.
Write in the function, not exactly. Because it gives you a parabola, definitely. It's not surprising. But that is not the graph of this function. Let me just remind you about... A function is not just the rule. Function is two things. The rule and the domain. In principle, if I do not give you the domain, I haven't specified the function for you yet. Yes, this is extremely important. But by default, when I ask GeoGebra to draw this, this is a convention that if I do not mention the domain is the largest possible set. It means that, is there any limitation for values of x that I can put in? No. Any x that you put in, this can be calculated. Yes? So there are no limitations. So this is why if you put this in GeoGebra, GeoGebra will draw the whole parabola for you. But now we know that this is not a complete parabola. Why? I am claiming that this is part of a parabola, not the whole parabola. Why? Yes?
Because area of a square cannot be negative.
No, so might be, I don't know. So might be this, yes, you are somehow right. Because we know that it should contain a maximum, and if it goes forever, at some point it will go below the x-axis. Yes, and then it becomes negative. That's one way to look at it, even though it's a little bit a strange way of looking at it. But that's correct. But that this is, so you are talking about the range, but you need to talk about the domain. So what is the domain of this function? If I just remember, let me just remind you something from Math 1C. If I write this function for you, and I just ask you what is the domain of this function, what is the domain of this function is the set of real numbers for sure. So if I ask you this question in the exam, just give you this function 12x, just give you this function, and I ask you what the domain is, you just tell me the domain is R. What does it mean? It means that any value for x you can choose. There are no limitations for the values you can choose. Do you remember the domain? For example, the domain of this function is not R, because there is a limitation for your choice for x. X cannot be 0. Yes? But in this problem, the domain is not R. Can you tell me what the domain is? Yes?
Positive numbers.
Not complete. That's somehow correct, but not complete. Yes?
Positive real numbers? What?
No? That's not complete. Non-negative is also good, but that's not complete yet.
Zero and positive.
So that non-negative means 0 and positive. So one part of it is correct. I agree with this part. But it is not finished. Let me ask you, can x be 10 in this problem?
Yeah, why not?
No?
Oh.
Be careful. It's real problem. Can x be 10 meters?
Ah, yes.
The value comes
No, because 2x plus y should be at most 12. So there is also a limitation for x from above. So what is that?
6.
6. Yes? So this is the domain. So this is the domain. So be careful. This function, if you want to draw this function by hand or by GeoGebra, you can ask GeoGebra to draw this graph for you. And then you need to limit yourself between 0 and 6 and cut that part of the graph and throw everything else away. That is what is left is the graph of this function. Is that understandable? So whenever you introduce a function, you not only introduce the rule, you have to also introduce the domain. Otherwise, it is not complete. Unless you use the convention. The convention is that if I give you the function just the rule, I mean the domain is the largest possible set. But in this case, the largest possible set is R, but it doesn't make sense in this setup because it cannot be negative, it cannot be larger than 6. Is that understandable? And then fortunately, this does not affect our result, but sometimes it does. Yes, because you see, let me ask you something. This function, this parabola, assume that this continues forever. Is there any maximum for this parabola? Yes or no? No. But if I limit myself to a portion of this parabola, for example, let me limit myself from here up to here. I only concentrate on this part of the parabola. Do I have a maximum for this leftover? Yes, and by the way, it doesn't occur in a turning point. It occurs at this final point. Is that understandable? So this have a really crucial effect sometimes. Here we got lucky. Because why we got lucky? Because when I put 0 here, the area becomes 0. And when I put 6 here, it becomes 0 again. So I was lucky that the maximum does not occur at this endpoint or that endpoint. It occurs at a middle point, which is the turning point. So I mean that if you want to be very strict, you really have to concentrate the endpoints as well. This is the topic of lesson in Math 4 or Math 3C, I don't remember. We will study this one. But here, I just want you to understand, sometimes I have this graph. If I give you the whole graph, there are no minimum points at all for this. But if I limit myself to some interval, it might happen that this also have a minimum. Yes? Yes or no? Is that understandable? I just want you to hear it or listen to it. I don't want to learn it that much because I will not give you questions like that. But I want you to understand there is something lurking for you, so you have to be careful about that. Here we were lucky. The maximum that we are interested in does not occur at the endpoints. But in principle, you should also check the endpoints. Yes? Is that clear? Okay, good. Okay, so I think now I stop here, and then we will continue later. Or let me see, is there any nice question here? I don't see these questions are higher level questions. So I think this is a good problem in the book. Let us try to think together. Okay, so this problem is something similar to this. You have a fixed right angle triangle. So the right angle, this is problem 3138. So exponent 2, yes, 2c. So they have given you a right angle triangle so that this side is fixed and it is 15. This side is fixed and it is 20. Everything is in centimeters. If I understand it correctly, I cannot read the text, but I think so you want to inscribe a rectangle inside here. Inscribe means putting a rectangle inside that, so that, for example, like this. Okay, so this is one of those rectangles that I can put. So one side of the rectangle lies here on this side, one side of the rectangle lies here, and this corner actually lies somewhere on the hypotenuse. This has an area. I can do it in a different way. I can make it a little bit narrower and longer. Yes? So how many of these rectangles you can imagine that I can inscribe inside this right angle triangle? Infinitely many. If I understand the text correctly, we want to find the maximum possible area. Which one is that? So I want to have the area, the maximum possible area. Yes? Let us solve this problem. I don't need to translate word by word. So what we want to find the maximum possible area of those rectangles. And then let us also answer this question. What are the dimensions of that particular rectangle? Yes? So every optimization problem, that is somehow also an optimization problem, yes? By the way, is there any meaning to ask you what is the minimum value? What is the minimum area?
It's infinitely small.
It's infinitely small, so there are no minimum, because I can make this narrower and taller. So I am making the area smaller and smaller, yes? So that is why they are not asking you about the minimum area. They are asking you about the maximum area. Okay? So, in these kind of problems, you shouldn't confuse yourself. You don't need to draw a lot of pictures. So let us take one of them. Okay? So let me give you some recommendations. So first of all, these problems could be, by the way, hard, because sometimes they also need geometry. So what you need to do, you need to find your target function. The target function is the function that you want to do optimization on it. Here, that's the area. So let us concentrate here, the area. So area is my target function, area of this hatched region, yes? And then if I want to calculate it, I don't know, I need to give numbers. But I don't have the numbers, so let me give letters here. So if you don't mind, let me just give it x, and then let me give it to be y. Yes? And then this area becomes x times y. And now your point is to maximize this function. But there is a problem here. How many variables you see in your function? 2 variables. One is x, one is y. So somehow you need to relate them together to get rid of one of these variables. Because if I ask you, is this a quadratic function? By the way, all optimization problems that you can solve somehow should be related to a quadratic function. This is not a quadratic function. So if you want to optimize here, you have to make it a quadratic function. Okay, so how can I do that? So this, I cannot do it unless I somehow get rid of y variable. Somehow. So how, and then you need to think. There is nothing that I can teach you. Problem to problem, this method is different. So here you need to discover the geometry somehow that you can relate x and y together. Do you have the idea how to do that?
So you want to get rid of y.
I want to somehow relate these two variables together. So if you don't mind, let me make it a little bit more clear because that it becomes very small now. So if you don't mind, let me clean this. Okay, so I will make it a little bit bigger so that you can see it better. Okay, so from here to here is x. From here to here is x. From here to here is y. I want to find a relation between x and y, knowing that this right angle triangle, this is a right angle triangle, and from here to here is 15, from here to here is 20. So what is the relation between x and y?
I mean, I mean, x is. Okay, actually, that's not a good angle. I was thinking maybe use the area like x equals a divided by y, but that wouldn't be.
No, it doesn't work in that way.
No, a.
I don't know why they have mentioned it here, because later in geometry we will learn some nice relations here. The only way that you can do it right now, if you haven't studied that chapter in the book, you have to use trigonometry somehow. Okay. Okay, let me pause recording so that if you can find a connection. So you know, I want to find a relation between x and y. If I know from here to here is 20, for example, if I ask you what is this value, you can answer me. What is this one? 20 minus x. Yes? And then I don't know, for example, what is this value? Is 15 minus y. And what is this one? That is also x. I think we studied similarity actually in Math 1C. So no, you can solve it without actually trigonometry. So now it is probably clear, isn't it? So what do you think about this triangle here
Oh, it's not.
and this triangle here?
They are similar.
They are similar. Why? I think it is not hard to convince yourself this angle and that angle are the same. And this angle is 90, this angle is also 90. So two angles of one of them is equal to two angles of the other one. So these two triangles are similar. Yes? If they are similar, what can I write? I can write 15 minus y divided by y is equal to this length divided by this length. Yes? This length is x. This length is 20 minus x. Yes, it is a hard problem, I say. I don't know why this book is very little bit sloppy in putting the stars or not putting them. Anyway, is that understandable?
Yes.
But it is a little bit complicated, but we can simplify it. So how I can multiply this by that, 15 minus y multiplied by 20 minus x is equal to x times y. Yes? And then I multiply 15 here, it becomes 300 minus 15x minus 20y plus xy is equal to xy. Agree? But then this xy and that xy are simplified. When I move it to the other side, it remains 0 here. And then I want to get rid of y. So let me make y alone. I move 20y to the other side, so it becomes 300 minus 15x is equal to 20y. Agree? And then I divide by 20 to make y alone. This divided by 20 is how much? 15. This divided by 20, it becomes 15 divided by 20. I simplify it by 5, 3 over 4. So this is much harder. You see, in the problem that I started, the relation between x and y more or less was trivial. Yes? Everyone immediately realized that x plus y plus x should be 12. But this is the hard part in this problem. The target function is x times y. I wrote x times y, but the point is that I am not having a quadratic function, and more than that, I have two variables involved in my problem. So I have to get rid of one of them. So I need to find, this is something that I cannot teach you how, you need to have experience of these kinds of problems. You need to find a relation between x and y. And then, I don't know, this is the way that I did it. Might be you can find another way to find this relation between x and y, that's up to you. But anyway, we want to find the relation between x and y, and finally after this a little bit long algebra, I succeeded to do that. Then what I do, I take it back and put it here. And then I will have my target function. A is equal to x, instead of y, I put 15 minus 3/4 times x. And then, if I multiply it, this multiplied by that is minus 3/4 x squared, and then plus 15x. And this is your quadratic function that you were looking for. Yes? And now I can safely call it a function of x. Yes? Do you agree with me? Now, you see, if you don't have these formulas in your head, you have to start completing the square here. So assume that you don't have these formulas. I want to use the formulas. But if you don't know the formulas, then what you have to do, you have to do all the squaring pattern and things like that for this case to be able to detect the maximum and minimum. Okay, so how can I answer this question now? That was a good question. I would say this is an A-level problem, really. So, how can I answer this question now? Oh, I shouldn't have cleaned this. Yes, we have it here. The maximum is there. If they ask about maximum, that is the formula. Can you tell me what are A and B here in this problem? What is A? A is minus 3/4, B is 15, and C is 0. Yes? So then if I ask you what is the maximum of A, so the maximum of A is equal to 4AC minus B squared divided by 4A. Yes, so 4AC becomes 0, B squared becomes 15 to power 2, 225, divided by 4 times A. 4 times minus 3/4, yes? So this becomes minus 225, 4 and 4 cancel, minus 3. So what is that? 75. Yes? 75, don't forget to write the units. Centimeters squared. Okay, so you see, I don't know which one they have asked. If they are asking about the maximum area, this is the end of the story. The maximum area of those rectangles is 75 square meters, square centimeters. But if they ask about the dimensions of that rectangle with the maximum area, this means that they are looking for x and y. Okay, but then this part becomes relevant. This is always maximum or minimum value, but this becomes how we achieve the goal. So x should be what? X should be minus b over 2a, so it becomes minus. Instead of b, I put this number 15, and 2 times minus 3 over 4. Instead of minus is minus, instead of b, I put 15, and instead of a, I put minus 3 over 4. And then simplify that. This minus sign will cancel that minus sign, so it becomes 15 over 3 over 2. So it becomes 10. 10 centimeters. And then if you want to calculate y, you take that x and put it here. So y becomes 15 minus 3 over 4 times 10. Yes? So this becomes 7.5 centimeters. Because this becomes 30 divided by 2 is 15 over 2. So 15 minus, that's correct. So it depends what they are asking. If I understand it correctly, they are asking about the highest area. Yes, the highest area is 75. Let me also check it. 31, 38. Yes, 75 centimeters squared. So they have only asked about the highest area. But how to achieve that? You need to take x to be 10 centimeters. That's also nice, you know. You need to go into the, that's also good. Could you predict this?
Yes.
I couldn't. So I don't know why. How did you predict this? So this is in the middle. This should also be in the middle. If I take this in the middle, 10 centimeters, and this one in the middle, then I will make this rectangle. Of course, this will meet exactly here if you draw the pictures correctly. So this one has the highest area. I don't know, how did you see that, Sergey?
I don't know, it was just intuition.
Yeah, that intuition worked here in this case, if that's correct. So this is the middle and this is the middle. So this square, this rectangle has the highest area. Yes, is that clear? So I would consider this topic a little bit hard because that is something really new for you. So I really recommend you, I will write something on the school stuff that you can start working on the problems. So most of these problems are word problems, so the questions are long, so you need to read and patient and try to solve these problems. Yes. Any questions? Okay, let me ask you one question. What is the domain of this function? If you want to draw the graph of this function, do you draw the whole parabola? Apparently no. Yes? Because what is x? X is some length here. And it cannot be negative. Of course, one possibility is that, of course, x cannot be negative. So x is not free to choose any real number because in this context, I am assuming that x is the length here and it cannot be negative. But is there any upper bound for x here in this problem as well?
20.
Uh,
I mean, can x be more than 20?
yes, 20 cannot be, yes. So it cannot be more than 20. Yes, if it is more than 20, it will go outside the bound.
And y would be
So if you want to draw this using GeoGebra, you ask GeoGebra to draw this for you, but you take that part between 0 and 20 and throw everything away. That will be the graph of this function, because the domain of this function is this interval. Is that understandable? Okay, good, thank you. So we stop here. We can have a little bit of break and then start working so that when I update you can work on it. Thank you.